Hey everyone. I thought we could look today at assignment assignment 10A. This is chapter 6 review with AP free response questions. All right. Graphing calculus is required for some problems or parts of problems. Okay. This one, problem number 1, the traffic flow problem comes from 2004 and is with calculator. Okay, so what do we see here? We've got this flow function as a function of time. We've got 82 plus 4 sine t over 2. And we're only looking at 0 to 30. Okay. The traffic flow is defined as the rate. Ooh, this is a rate function. Passed through an intersection measured in cars per minute. Cars per minute. And I imagine this is going to be a number of minutes. T minutes. Great. So part A. To the nearest whole number, how many cars pass through the intersection over the 30-minute period? Well, if I integrate that rate, I'll get the number of cars. So part A is going to be the integral of big F from 0 to 30 dt. And no, I'm not going to try it by hand. Don't try it by hand. That's crazy. Instead, this is a calculator portion, so you should be using your calculator. There we go. Using my calculator to type this. I imagine I'm going to be using this function a bunch of times. Oh, and look, it's triggy to boot, so I better make sure that I'm in radians for this. So mode, radians, good. And now I need the integral math integral y1 comma x comma 0 comma 30. And remember, they did say to us to the nearest car. So this integral is 2474 cars. Okay. Part B, is the traffic flow increasing or decreasing at time equal to 7? Well, remember, flow is this function. I want to know if this function is increasing or decreasing at time equal to 7. If I want to know when big F is increasing, I better look at big F prime. So, part B, I want to know big F prime of 7. If big F prime of 7 is a positive number, then flow is increasing. If big F prime is a negative number, then flow is decreasing. Oh, and conveniently we have this in our calculator, and this is a with calculator question. But now I want the derivative of big F. So I'm going to go back to math, and I'm going to choose n derivative of y1 comma x comma 7. And I find out that f prime is negative 1.873 since f prime of 7 is less than 0, flow is decreasing. All right, that was part B. Part C. See how some of these are circled? The circled ones specifically apply to stuff we need to be comfortable with for our Chapter 6 test. Okay? And so this one is circled, part C. What's the average value of traffic flow? Well, I want the average value of that function. I need to use the average value formula. And are we on the interval from 0 to 30? No, we're not. We're going from 10 to 15. 10 to 15, big F dt. There's the average value of flow, right? It's the average value on the interval they asked for of the function they want to know the average value for. So let's do that integral and then multiply by 1/5. Well, let's see what we get. We want math integral y1, comma, x, comma, 10, not 0, to 15. So I'm going to have 1/5 times 409.496 to 149. Okay, and indicate units of measure. I'll be right there. Well, I could say, hey, flow is in cars per minute. And if I integrate cars per minute, I get the number of cars. Times, whoa, what are these units? Times 1/minutes. Oh, right. We're just looking for the average value on the graph, the average y value on the graph of flow, and therefore we should have those same units. You could stop here, of course, or if you divide by 5, you should get 81.899. And these are cars per minute, right? Because the integral gives us cars, and we're dividing by these minutes here, or multiplying by 1/minutes. So cars per minutes, no justification, no, just indicate units of measure. And part D says, what's the average rate of change in flow? Average rate of change is f of 15 minus f of 10 over 15 minus 10. This is our average rate of change. Remember, these are cars per minute for f over minute. So this is going to be cars per minute or cars per minute squared. So how do I find f of 15? Well, I like my table feature for this problem. So I go over to my table, and I type in 15, and I type in 10, and so these values are 85.7519999071 minus 78.16430290013 over 5. Let's see what I get. 85.751999071 minus 78.16430290013. And I want to divide that number by 5. And so I end up with 1.518 cars per minute. Yes, you could stop here and say cars per minute. Okay, there you go. So that's a free response question. And you're budgeted at 15 minutes on average for these. And look, we just got through it in 8. Yes, I know I was doing it. Yes, it would take you longer. But no, really, trust me, by the time you get to the AP exam, you'll be doing them in 8 to 10 minutes as well. Okay, problem number 2 has only one part to it. There seems to be this graph here. This is 1, and here. This is g of x. This is f of x up here. And the question says, A, find the shaded area. Well, okay, we've been told that f is equal to 2x 1 minus x, and that g is equal to 3x minus 1 square root of x. Okay, and so how do I want to do it? Well, 2 things I want to pay attention to. This question, which came from 2004, was also with calculator. So 1, I'm going to be using my calculator. 2, I want the shaded area. So I'm going to be doing top minus bottom, top minus bottom, top minus bottom, and adding up all of those lengths. So for me, it's just going to be the integral from 0 to 1 of f minus g. That's all they want here. So I do have to type these formulas in. You could type them in, like in y1, you could type f, then minus g. Maybe do that. I was thinking I would not do that, but yeah, why not? 1 minus x. So there's f, and I'm going to subtract from that g, which is 3 times x minus 1 times square root of x. Close that parenthesis. Okay, and what do we want? We want to integrate that y1 function in terms of x from 0 to 1. So this problem turns out to be wicked easy if I use top minus bottom, and much harder if I try and do it any other way. So my integral here, 1.133. There's my shaded area. Done. Moving on. All right. Problem number 4 comes from 2003, form B. There's so many different forms that are used on the AP exam. It is amazing. Okay, so this one says the particle moves along the x-axis. Its velocity is given as v equals -1 plus e to the 1 minus t, and this is without calculator. Okay, so we're going to be expected to be comfortable working with that, but this is velocity. Great. No negative time. They say time starts at 0. Find the acceleration of the particle at time equal to 3. Well, I know that acceleration is v prime. So I want to take the derivative of this. Derivative of that is 0. The derivative of e to the is e to the times the derivative of that power, which is -1. And we're looking for a of 3. So that's going to be e to the 1 minus 3 times -1, which is e to the minus 2 times -1. And you could stop there, or if you prefer, you could do something like -1 over e squared. There's my acceleration. I don't have to put units. I don't have to justify. Just that answer for part A. Part B says, is the speed increasing at time equal to 3? Well, remember, we said that speed is increasing when v and a have the same sign, okay? And the sign of a of 3 is negative. Well, let's find out what v of 3 is. V of 3 is -1 plus e to the 1 minus 3. So this is going to be -1 plus 1 over e squared. Yeah, many students struggle with this. But here's what I want to say. This is 1. E is close to 3, 2.71. Close to 3. 3 squared, 9. 1/9. How does 1/9 compare with -1? Yeah, sorry, that's going to be less than 0. So velocity is less than 0, acceleration is less than 0, so I can say since v of 3 and a of 3 are both less than 0, speed is increasing at t equal to 3. Okay? All right, that was part B. How about part C? Part C says, find all the values where the particle changes direction. Okay, so remember, changes direction is when velocity goes from positive to negative or goes from negative to positive. not just a zero velocity. If I go from negative to negative, I didn't change direction. Okay, in order to change direction, I have to have a sign, S-I-G-N, change on V. Yeah, I have to have a sign change on V for the particle to change direction. Well, let's think about this V thing we've got here. When is V equal to 0? Well, that's going to be when 1 equals e to the 1 minus t. We take the ln of both sides. We get 1 minus t equals 0, where t equals 1. So 0 and 1. If I plug in a number here, and remember, this is v, not v prime. If I plug in a number over here, like even 0, I'm going to have e minus 1. That's positive. And if I plug in a number over here, like when we plugged in 3, this turned out to be 1/9. This was -1, and we had a minus. So find all the values where the particle changes direction. The particle changes direction when V changes sign. So this only occurs at t equals 1. That's a 1. Okay, and then part D, find the total distance traveled. So, yeah, I'm not sure we're comfortable yet with total distance traveled. With total distance traveled, think about integrating velocity to get how far you traveled. But if my velocity graph goes below the x-axis, my integral, starts, this negativeness overwhelms that positiveness. And so that's going to be kind of problematic. And so we have two ways of dealing with this. One, we could integrate the absolute value of v from 0 to 3. But I don't know how to integrate absolute value by hand. I would do this on the calculator, but for us, I think we're going to do this v dt minus 1 to 3 v of t dt. Why? Well, the integral here is going to be positive, but then from 1 to 3, the value of my integral is going to be negative. If I'm looking for total distance traveled, that's like total area. I've got to flip this amount up. I've got to take this negative quantity and make it positive. So minus a negative will give me the positive I'm looking for. So now I have to integrate v. Here's v, and I need to integrate it. So if I integrate v, I'm going to get s equals negative 2. And now what about the antiderivative of this? Well, I'm thinking 1 minus t. But wait a second. If I take the derivative of this, which would bring me the velocity, I'll get that, but I don't see a negative here. And if I take the derivative of e to this stuff, I will have e to this stuff, but the derivative of the inside is a minus. So, since there's no minus here, there must have been something present in the original function, so that when I took the derivative and using chain rule came up with that minus, there was already a minus there to turn this into a positive. All right, and so I want to evaluate this negative t minus e to the 1 minus t from 0 to 1, and I want to subtract from that negative t minus e to the 1 minus t from 1 to 3. So let's see what happens. Okay, if I plug in a 1 minus, oh, there it is. It's negative 1. 1 minus 1 is 0. E to the 0 is 1, so I have another minus 1. Minus, what happens when I plug in a 0? 0 minus e. Okay, so that's going to be plus e minus 2 plus e. This is positive. Now we're going to subtract evaluating this one by plugging in a 3. That's negative 3 minus e to the minus 2 minus negative 1. And if I plug the 1 in there, I get another minus 1. So that's going to be minus 3 minus 1 over e squared. I feel like I dropped a sign. Did I drop a sign? No. Okay. Minus a minus is plus 2. Okay, so this plus 2 takes care of one of those. And now I want to subtract these, so I'm going to add 1, negative 1, and I'm going to add 1 over e squared. There you go. That's the total distance traveled. Okay, but I really don't think total distance traveled shows up in our tests until Chapter 7 test, so I think you might have some time on that. Okay, let's get a move on. On the back, we've got problem 5. This is 2003 Form B without calculator again. We're given a graph here. Our graph is something like this, where this is 4, 5, 6, this is the point 2, 4, and this is 0, 0, and we're told that this graph, 7, 1, we're told that this is a graph of f. And then we're told that g equals 2 to x of f of tpt. So if I integrate this from 2, I get g. All right, well, first, again, before you start reading the questions, it would be really good if you came to the understanding of what this graph was with respect to g. And what I notice is, if I take the derivative of both sides, I get dg dx, which is g prime. And over here, derivative undoes integral, this goes in here, I get f of x. So this graph of f is also g prime. All right, so part A says find g of 3. Okay, well, g of 3, no problem. I know that g of 3 is defined as the integral from 2 to 3 of this f graph that I'm looking at. So from 2 to 3, well, I don't know what the y value is there. And you know what? AP thinks you should be able to, at this point in time, write the equation of that line to find out what the y value is there at 3. No, really, they do. So we're going down 4 and over 2. So we know our slope is negative 4 over 2, or negative 2. And we've got an ordered pair on the graph, or another ordered pair on the graph, 4, 0. So this line is y minus 0 equals negative 2x minus 4. So that's y equals negative 2x plus 8. And I want to know what's y equal to at 3. Negative 2 times 3 plus 8 is 2. And yeah, you might have guesstimated that, but it's good to know for sure. So I know that I'm looking for the area of this trapezoid. The area under this f curve from 2 to 3. I know that this is 2 and that is 4, and I know that the distance from 2 to 3 is 1. So that's going to be 1/2. The height is 3 minus 2, base 1 plus base 2. So that's going to be 6 times 1 is 6, divided by 2 is 3. G of 3 equals 3. Done. Next, G prime of 3. Remember, this is a graph of G prime. Look, at 3, the y value is 2. So I know that g prime of 3 is 2. And then they say, hey, what's g double prime? Well, remember, g double prime is the slope of g prime at 3. And didn't we already find the slope of that line segment to be -2? Oh, so at first I thought it really sucked that College Board wanted me to write the equation of this line, but then it turned out that, in fact, my next two questions needed information from the equation of that line. Ah, thank you, College Board. You were looking out for me. All right, part B. Find the average rate of change on G from 0 to 3. So G of 3 minus G of 0 over 3 minus 0. Now, we know that G of 3, what was it? Oh no, it's gone away. G of 3. G of 3, 1/2, 1, 6 was 3. Okay, so G of 3 is 3. What about G of 0? Well, G of 0, we're told here that G of x equals the integral from 2 to x of this graph. So I don't want to integrate backwards. I'm going to flip this, put a negative out in front, and say 0 to 2. So on 0 to 2, I just need to find the area of this triangle. This triangle has a width of 2 and a height of 4. Negative 1/2, 2 times 4. So G of 0 equals -4. So minus 4 over 3. And so I end up with 7/3. That's my average rate of change, is the average rate of change on G from 0 to 3. Good. So what's next? Part C. For how many values of C on 0 to 3 is G prime equal to the average rate of change found in that last part? Oh, that was 7/3, wasn't it? So remember, we're looking at a graph of G prime. G prime. At some x value, G prime, the y's, are 7/3. Well, this is 6/3. This is 12/3. Here's 7/3. Yeah, twice. I see twice. How many times? G prime equals 7/3 twice. On 0 to 3, because, I really kind of want to use something like intermediate value theorem here. But I sort of feel like that's going to be overkill. So I think I'm just going to say twice on 0 to 3, once on 0 to 2, as G prime goes from 0 to 4, and again on 2 to 4, no, 2 to 3, as G prime goes from 4 to 2. Okay. Yeah, that's how I'm handling that this morning. Okay, next. D, x coordinate of each point of inflection on the graph. And point of inflection on G. So we're looking for inflection points on G, and this is a graph of G prime. Well, remember, when G prime goes from increasing to decreasing, or from decreasing to increasing, those are places where G double prime would be 0 or undefined, and therefore G would have inflection points at t equals 2 and t equals 5, where G prime goes from increasing to decreasing or decreasing to increasing. Okay. That's my justification. Good. All right. 2 more questions? Not sure I can make it, but we'll give it a try. This one is 2004 with calculator again. Comes with a little graph, as that, and that looks like a semicircle, and then down. Here, this is 1, this is 2, 1, this is 4, -1, this is 3, 2, and this is -5, -2. Okay, it's actually going to be down there because these are the same. All right, what do they ask me here? They also tell me that G equals the integral from -3 to x of this graph. And again, what is this graph? Well, if this graph is f, I take the derivative of both sides, and I get that G prime equals f. So this is G prime. If I want to know G of 0, G of 0 is going to be the integral from -3 to 0 of f. So from -3 to 0 is this. Okay, well, that's just a trapezoid. So G of 0 is going to be 1/2 0 minus a -3 times base 1 plus base 2. And you can stop there. You can go further if you want to 9/2. We're also asked to find G prime of 0. This is G prime, and so G prime of 0 is 1. Okay, and that's it. Part B. Part B says find all the values on the open interval from -5 to 4, where G has a relative max. Well, if G has a max, then I'm looking for G prime goes from positive to negative. Notice in this problem, they've used parentheses, so no including the endpoints. Because most American kids forget to check the endpoints, and College Board knows that, and they don't want those kids getting lower AP scores. So, let's take a look at our G prime sign chart. Since G prime equals f, I see from -5 to -4, G prime is negative, and then from -4 until I get to 1, G prime is positive, until I get to 3, positive again, and then G prime is negative. So if I'm not looking at endpoints, there's a min. That's neither a min nor a max, but here's a max. Only one max on G on -5 to 4 with parentheses, where, at x equals 3, because to the left of x equals 3, G prime equals f is greater than 0, and to the right of x equals 3, G prime equals f is less than 0. All right. Find the absolute minimum. Well, let's have that sign chart again, that G prime sign chart. -5 to -4, 1, 3, and 4. Okay, so we had minus, we had plus, we had plus, we had minus. So I've got a min here at the endpoint. That would have been a max if it were included because my function decreases from there. But I have a min here. So mins at -4 and 4. But we're asked to find the absolute min on the closed interval. Yeah, so I've got to consider both of these. So I need to think about what g of -4 equal to and what g of 4 is equal to. I'm going to need to evaluate each of these. Okay. And I've got this definition here. G of x equals the integral from -3 to x of this graph. So g of -4 is going to be the integral from -3 to -4 of this graph. However, that has me integrating backwards, and I don't want to integrate backwards, so I'm going to pull out that negative and go from -4 to -3 on this graph. Well, from -4 to -3, I have a triangle. So I don't need a calculator for that. I'm going to do 1/2 base of 1 times the height of 2. Okay, so from -4 to -3, I get 1. But don't forget that negative. So -1. So I have the minimum at -4 has a y value of -1. What about the minimum at +4? So if I integrate from -3 to +4, this f function, from -3 to +4 includes all these little bits. First, we have this trapezoidal bit. That's going to be 1/2. -3 to 0 is 3. Base 1 is 2. Base 2 is 1. Plus this piece in here. And I believe this piece in here, yes, this is a semicircle. My integral here would be great, but I don't want to integrate that. Instead, I want to think about this rectangle minus this semicircle. Okay, so the area of the rectangle, which starts at 0 and ends at 2, this is 2. The height is 1. 2 times 1 is 2. So I know that's 2 minus, we've got to take away the semicircle. The radius of the semicircle is from 1 to 2, or 1. So pi 1 squared, but that's a whole circle. You only want half a circle. So we're going to add on 2 minus pi over 2. And then we've got this little triangle here, which is 1/2. The base is 1. The height is 1. So we're going to add another 1/2. And now we have this piece here. This is -1. This is +1 because we're going from 3 to 4. And so that's 1/2 1 times -1. And so that's -1/2. So those are going to cancel out. And we're going to be left with this. And in another universe, I would have tidied that up to one number. But in 2 minutes, I'm supposed to be in a Zoom with you. So I'm going to quickly say you can leave it because it's fair response. Finally, we want the x-coordinate of each point of inflection. No, that was the wrong question. We did the absolute min. Oh yeah, I did need to finish that one, didn't I? So I could compare those minimum values. Well, I'll let you do that. And yes, find all the values on the open interval -5 to 4 where g has an inflection point. So g has an IP when g prime goes from increasing to decreasing or decreasing to increasing. When does that happen? Well, I go from increasing to decreasing, so at x equals -3. At 0, g prime is going from decreasing to decreasing. Many students leave this one out. X equals 1. They see that it's an x-intercept, but they don't see that g prime is decreasing to the left of that point and then increasing to the right. And then at x equals 2 as well. G prime goes from increasing to decreasing there. All right. Oh, and it looks like at some point my camera tilted. Well, that's just fabulous. Sorry about that, everyone. I just noticed. Okay, well, I guess we're going to have to wait on that last question for another video. Take care, everyone.